Okay, we're asked to evaluate this using trigonometric substitution. Let's go through the steps. And the first thing I did was I let x equal 2 sine theta. And then I took the derivative of that, the differential dx equals 2 cosine theta d theta. And then I made a substitution. That's all I did. All right? So, x cubed, what would that be equal to? 8 sine cubed theta. And then x squared, would that be 4 sine squared theta? And what's dx? Well, dx we just did is 2 cosine theta d theta. Now, of course, the extent of this now is to figure out what's going on here. And let me just go through that with you, because we want to get to this line over here to make sure we can agree with that. And what do you get over here? Let's write this down. I'm just going to write the integrand down. It's 8 sine cubed theta. I'm going to factor a 4 out from that radicand, and the square root of 4 is 2. And then I'd be left off with 1 minus sine squared. All right, now, as long as I pick the angles carefully, it's okay to take the square root of that and not worry about the sine of it. And I'm going to say, pick the theta between, I'm going to say, minus pi over 2 and pi over 2. All right? If you do that, what are you going to get? You get 1 minus cosine squared. I'm sorry, 1 minus sine squared, which is cosine squared. And the cosine squared in an interval is certainly not negative. So let's write this down. It's because it's getting cosine of theta. All right? So we're kind of moving. We're at this stage over here. I'll write the 2 down now, and you get cosine theta. And I just want to do this integrand. All right? I want to do this part over here. See if I get what they said I should get. Well, 8 times 2 is 16 times 2 is 32. I definitely see that. All right? Again, 8 times 2 is 32. I see the sine cubed, and I see the cosine squared. All right? All right, now what do I do? Go back to the last section, and what I did was I looked at the sine function, and I borrowed a sine squared from that. Let me get my eraser out. And again, I'm going to try to concentrate on what we're looking at now. We're looking at this line, and when I get to the next line, again, I'm still looking at that integrand. So I took the sine cubed, and I wrote the sine cubed as sine times sine squared, and sine squared is 1 minus cosine squared theta, right? That's where this is coming from here, all right? Then what I did, I made another substitution, all right? The second substitution I'm making. I'm saying u is cosine theta, all right? Now, if you do that, I just want to point out, kind of looking at it, and again, be very careful about this. So if I say u is cosine theta, the du is relatively simple. I got to work with that integrand, though, right? So I'm working with this integrand here. See what I get. So you get 32. Let's see. I would get, I see the sine theta, d theta. That's actually minus du. All right? And then when I get over here, I get 1 minus u squared. And then I get u squared here. And what would that give me? Well, I'm going to pull the negative sign on the inside. So it's 32. Then you get u4 minus u squared du. Make sure you have that written down somewhere. And that's written right over here. All right, u4 minus u squared. All right, so I'm kind of moving along. And I'm going to get my eraser out again, just talking through the key at this point. And for the most part, in the later part of the problem set, I will be doing this, all right? Before I go forward, I want to point out we have made 2 substitutions already. We made this one, and we made this one. And we're on this line over here. This is a rather easy integration to do. And what do you get? Well, you get u5 over 5 minus u cubed over 3 plus some constant integration, all right? And then, I plug it in. What am I plugging in? Well, I got to know what u is, and u is cosine. So I just plugged it in. That's all I've done, all right? Here comes the tough part. I got to go backwards to the original problem, which is the problem of x's, right? And so I got to remind myself what that is. And it's right over here. And let me write this down for you. X equals 2 sine theta. And we set up saying that the sine of theta is between minus pi over 2 and pi over 2. All right, let's take a look at this. You get x over 2 equals sine of theta. I want to do my right triangle now. And what do you get over there? This is the theta. This would be x. And this would be the 2. And this would be the root of Pythagorean theorem, 4 minus x squared. all right? I'm running low on power, I have to plug in my power in now. All right, so I think I can start doing this now. And what I mean by that is I know the cosine of theta. And the cosine of theta is going to be the root of 4 minus x squared over 2. So I want to put out, really all I'm doing over here is plugging that in. All right, I'm just plugging this in here and here. So, I write it down. I got that, and I'm kind of, plowing my way forward now. And let me get my eraser out. I'm pretty sure I'm back in the land of x's at least. There's this over here. And I want to tell you where we got to right now. We're here. All right, now I realize that it looks awful. It really does. But I want to go through it with you. And part of doing that is just doing the arithmetic in the problem. And let's take a look at it. And the first thing I notice is I really do have, the fifth power of that, which is 32. All right, let me write that down for you. 32. I have 1/5. And this would be 32 over here. And then what do you get? Well, you get, 4 minus x squared to the 5/2 power. Minus, let's do the next one, that's 1/3. And you're going to get 4 minus x squared to the 3/2. And that's going to be 8. And there's a plus c there, all right? Okay, what am I going to do now? I guess I have to multiply through by 32. And what would you get? Well, just across the first term, you get this. And you certainly have the fifth, and the 32 disappears. The second term, what do you get? Well, remember, you got the 8 here and the 32 there. You would get 4. You have a 3 in the bottom, and you get this over here, all right? And then what I did, which may seem strange to some people, I factored it, all right? Now, before factoring it, I want to get a common denominator. What's common denominator going to be? Let's write this down, plus c. And you get 15. And you would get, be very careful here, it's going to be 3. And then you get 4 minus x squared to the 5/2 minus, what would you get there? It would be a 20. 4 minus x squared to the 3/2. And what I would probably do is, in factoring that, I'm certainly seeing a lot of things going on over here. 15 plus c. And looking at it, I'm going to factor out 4 minus x squared to the 3/2. And what would you get? You get 3. Then you get 4 minus x squared. And then you get minus 20. All right, let's see if we can do that. So, 4 minus x squared to the 3/2 is actually 4 minus x squared root of 4 minus x squared. I just took care of this business. I got a 15 in the bottom. And I just took care of this. And I'm going to do this now. All right, let's see if we can put that down. And what do you get there? You get 12 minus 20. 12 minus 20, which is minus 8. And then you get what? Minus 3x squared. Well, I'll be honest with you, it looks kind of strange to me. I'm going to factor out a minus 1 now. I'm going to sort of put them in, I'm going to reorder them. Factor out a minus. I get 15. 3x squared minus, not minus, but plus 8. Again, I factor the minus 1 out from this. And then I get 4 minus x squared. And then I get the root of 4 minus x squared. All right, put a box in that over here and indicate that's where I stopped in the k right there. And again, clearly indicated over here with everything that we said it would be, all right? Everything is working out as advertised. Thank you.